In this next video, we want to talk about compound and continued inequalities so that we can combine this when we're talking about absolute value inequalities. So let's take a look at what a compound inequality is. First, a compound inequality is basically two inequalities joined by the word or. A compound inequality then means that I either satisfy the inequality on the left or I satisfy the inequality on the right. Typically, their graph results in what I call a split shape, which you'll see right here in the upper right. I also call this the two thumbs out situation. This is different from what is called a continued inequality. A continued inequality is more like a three-part inequality where you have a left, a middle, and a right with two inequalities appearing in the same line. These are AND problems. They typically result in a dumbbell shape, which looks something like this. Let's take a look at the continued inequality or the OR inequality we had in the beginning. If we're looking at this equation, then I either need to satisfy the inequality on the left or the one on the right. Let's look at the one on the left. First, to isolate x, I need to move the 5 by subtracting 5 from both sides of the inequality. This is the addition property, which does not change the solution, and it gives me 3x less than or equal to -9. From there, I can divide both sides by 3. This is the multiplication property of an inequality. Because I'm dividing by a positive 3, I do not need to reverse the symbol, so it stays the same direction throughout. I get for the left inequality that x is less than or equal to -3. On the number line, the or equal to will give us a solid dark ball at -3 to the left of 0, and because the variable is on the pointed or small end, it will go to the left. What about the right side of this OR inequality? This says x plus 8 must be greater than or equal to 15. If that's the case, I can isolate x by subtracting 8 from both sides to get x is greater than or equal to 7. Again, the OR equal to will give me a solid ball at 7, and then from there, I can represent this as a solid ball at 7 and going off to the right because this variable is on the wide or larger end of the symbol. In interval notation, it would look like this. Starting at the far left side of the number line, it would start at -infinity, which you see here with the round bracket, comma, going to -3. A solid ball would result in a square bracket. This is the union symbol, which means OR, and then we would have another square bracket at 7, picking up and moving off to the far right of infinity with a round bracket. This notation here is the interval notation for that solution set. What about the continued inequality, the second one we saw, which is more of an AND situation? If we're looking at this AND situation, then we expect to see a dumbbell type shape when we graph it on the number line. Because it has 3 parts, if I want to move the 7 being added to 5x in the middle, I need to subtract the 7 from all 3 parts, from the left, the middle, and the right. I'm trying to isolate the variable term, the x, in the center part. That leaves me 5x in the center. 2 minus 7 gives me -5 on the left, and 12 minus 7 gives me 5 on the far right. Then I can apply the division property of the inequality, and when I divide all 3 parts by +5, it does not reverse the symbols, which stay in the same direction throughout the entire problem. This results in the solution -1 less than x less than 1. In other words, x is between -1 and 1. Notice that these symbols point in the same direction. That will give us this dumbbell shape. Because I don't have or equal to, they're both round, and these are both open or empty circles. And it's all the numbers between -1 and 1. We could have solved this as a compound inequality written as two inequalities joined by the word AND. that would tell us that -1 would need to be less than x and x is less than 1. But again, that would result in this dumbbell shape you see here. Now, moving on, let's take a look at the next piece. In this part, we want to put together the absolute value with the inequality. We know from what we did earlier that when the absolute value of x equals 3, then either it is 3 or it is -3. We get two possible solutions, which corresponds to two separate dots on our line graph. If we put this with an inequality, like this one, this reads the absolute value of x is less than or equal to 4, then we can interpret that as the distance of x from 0 on the number line is less than or equal to 4 steps away. That means that x has to be within -4 and 4. If it's further away than that, then it's more than 4 steps. So when we have an absolute value less than or absolute value less than or equal to, this translates as one of our continued inequalities, or an and, the dumbbell shape you see here. If we have greater than or equal to, then we can interpret that as the distance of x from 0 on the number line is greater than 6, or whatever the number is over here on the right. That means that either it has to be beyond 6 on the right or below -6 on the left. If it were closer than that, it would be fewer than 6 steps away from 0, and that would not satisfy the absolute value being greater than 6. This gives us this split shape, not the dumbbell shape we see here, but this split apart shape or two thumbs out we see here. That results from an absolute value greater than or absolute value greater than or equal to. Let's look at the notation. Once we've isolated the absolute value on one side of the inequality, if the absolute value is less than a number or less than equal to a number, we'll drop the absolute values and write it as a continued inequality, where what's inside the absolute values is between -a and a, or less than or equal to, greater than or equal to, this way. Let's look at an example. In this case, we see we have an absolute value, -4, less than or equal to 2. Just like in the equations, we need to isolate this absolute value before we can drop it, because it may end up being something other than what we think. So first, we move the -4 by adding 4 to both sides of the inequality. The addition property does not change the solution set, so the symbols do not reverse. We simply move the -4 by adding 4. That will give me a 6 on the right and isolates my absolute value of 6x minus 1 on the left. I have an absolute value less than or equal to. I will drop the absolute values, put 6x minus 1 here in the middle, as you see here, and I will put it between 6 and the opposite of 6, or -6. So it goes between 6 and -6. This should result in a dumbbell shape. To isolate x, I need to add the 1 to remove the -1 next to 6x. I add 1 to all three parts. On the left side, this will result in a -5 less than or equal to 6x less than or equal to 7. Now, to solve and isolate x, I divide by 6. When I divide by 6, I get -5/6 on the left and 7/6 on the right. Now I need to translate that into the number line graph. That will give me the 0 in the middle, -5/6 on the left, 7/6 on the right. Both balls need to be solid because both symbols were or equal to. And it's between because x is larger on the wide end of -5/6, but smaller on the narrow end of 7/6. That's our solution here. How would we show this in our notation? Let's draw the notation into the screen. To put in the notation, I need to represent the solid ball and the or equal to with a square bracket. but I have to follow number line order. So on the far left, I have -5 divided by 6. Then I have a comma. Then I must show the number on the far right, which is 7 divided by 6. Again, this is a solid ball, which I need to represent with a square bracket. That would be how I would write this in interval notation. Let's take a look at the other case. What if, once I've isolated the absolute value, it is not less than or less than equal to, but greater than a number or greater than or equal to a number? In that case, the distance is further from 0, which means this must be a split situation or a thumbs out situation. I'll drop the absolute values and I'll rewrite it as a continued inequality connected with the word or and not and. So one of them will be to the left or below -a, and the other will be above or to the right of +a. Here's what it would look like. Let's look at an example. In this equation, you can see I have absolute value of the quantity 2a minus 6, closed quantity, minus 1 greater than 2. I can't figure out what it's going to look like till I've isolated the absolute value. To isolate the absolute value, I need to remove the minus 1 by adding 1 to both sides of the inequality. Adding and subtracting does not change anything in the inequality. This will give me a 3 on the right and isolate the absolute value on the left. But this says the distance is more than 3. To be more than 3 steps away from 0, I have to be to the left or on the small end of -3, or to the right or on the big end of +3. So I take what's inside the absolute value, write it here on the left. It's either below or on the little end of -3 or above or on the wide end of +3. Then I solve the two inequalities separately. To isolate A, I need to add 6 to both sides of the inequality on the left. That gives me 2a is less than 3. Then I divide both sides by a +2. When I divide both sides by +2, that does not reverse the symbol because the 2 I'm dividing by is a positive number. That gives me a is less than 3/2. What about the inequality on the right? This one I solve similarly by adding the 6. I result in 2a greater than 9. To solve for a and isolate it, I divide by the +2, which does not reverse the symbol, and that gives me a is greater than 9/2. But it is not possible to be in both of these places at once. That's the importance of the word or that happens when the absolute value is greater than or greater than equal to a number. Here you'll see that I have 3/2 with an open ball at 3/2. And then the arrow must go to the left because the variable a is on the little end. The other side, I have 9/2 and the variable a is on the wide end. So I have an open circle here at 9/2, but a, the variable's on the wide end, which is go right. How do I translate this into interval notation? I must start at the far left and move my way across from left to right. The far left is the arrow representing -infinity, must be around parentheses, comma, 3/2. The 3/2 is an empty circle, so I use a round parentheses. The U symbol is union, which represents or. Then for 9/2, I have an open circle, which is a round parentheses, continuing towards the arrow, which goes off to the far right, representing positive infinity, always with a round parentheses. There are some special cases here as well, and we need to talk about these. They do happen occasionally, and you need to be looking for them. You know that on an exam you can expect to see at least one of these. There are two special cases, one for each one. Let's look at this one first. What if I isolate the absolute value and it's less than a negative number? Let's think about what this means. This means the distance from 0 on the number line is less than -2. How can you be fewer than -2 steps from anywhere? This is not possible. Absolute values can never be smaller than 0. They're not ever going to be smaller than a negative number. That means that if the isolated absolute value is less than or less than equal to a negative number, there is no solution. Let's look at the second case. If we're looking at the second case, we have absolute value of something greater than a -8. Well, think about what this means. The distance of 4x plus 8 from 0 on the number line is more than -8. Well, this is always true. There's no value I can find for x for which this won't be true, because an absolute value at its very smallest is 0. It's either a positive number or 0, and those will always be greater than any negative. In this case, every real number for x will work, so our solution is everything works. Those are the two special cases, and this ends the lesson on absolute value inequalities.